Consider this expression: 3 times 3 times 3 times 3, 4 times. Is there another way of writing this expression? It turns out that there is. Instead of writing 3 4 times, you can just say this is 3 to the 4th power. Thus we have the use of exponents. Exponents is a nice way of writing a repetitive expression that looks like this. So basically, anytime you have repeat multiplication, you can use exponents to simplify the expression. So for example, let's say if we have 5 x variables multiplied to each other, instead of writing it in its expanded form, we could say this is simply x to the 5th power. Another example, let's say if we have x plus 5 times x plus 5 times x plus 5 3 times. This is equivalent to x plus 5 raised to the 3rd power. Consider these 4 examples. I'm going to write them on a board, but go ahead and write them another way using exponents. Feel free to pause the video as I write these problems on the board. Okay, let's start with the first one. So we have a single 4, which you can say 4 to the 1st power, or just leave it as 4. And then we have 2 x variables multiplied to each other. So x times x is simply x squared. And there are 3 y variables, so we can write it as y cubed. So this single term is called a monomial. And so the answer is 4x squared y cubed. Now what about the second one? We have 1, 3. We have 2 a variables and 3 b variables. So this is going to be a squared b to the 3rd. In the next example, we have 3 negative 5. So it's a negative 5 to the 3rd power, which we can reduce it to a single number. Negative 5 times negative 5 is positive 25. And positive 25 times negative 5, that's negative 125. In the last example, we have a 7 and 2 y plus 2 terms. So it's 7 y plus 2 squared. So now you know how to take an expression in its expanded form and write it as a single monomial. Sometimes you may have problems where you have to work it out in reverse. So for example, go ahead and expand this monomial completely. So 8 can be written as 2 times 2 times 2. X to the 4th is x times x times x times x. Y to the 5th is 5 y variables multiplied to each other. So that's 8x to the 4th y to the 5th. Here's another example. Go ahead and expand this one. Let's say we have 9 c to the 4th d to the 3rd. 9 is 3 times 3. C to the 4th is c times c times c times c. D to the 3rd is d times d times d. So that's how you can expand certain monomials. Sometimes, in a typical homework assignment, you might be asked to evaluate certain expressions. Go ahead and evaluate 2 to the 4th power. The first thing I would do is expand it. This is 2 times 2 times 2 times 2, 4 times. 2 times 2 is 4. And 4 times 2 is 8. 8 times 2 is 16. So 2 to the 4th is equal to 16. Try some more examples. Go ahead and expand 3 to the 3rd and 10 to the 3rd. Evaluate the entire expression. So 3 to the 3rd is 3 times 3 times 3. 3 times 3 is 9. 9 times 3 is 27. And so that's the answer for the first one. 10 to the third power is 10 times 10 times 10. 10 times 10 is 100, and 100 times 10 is 1,000. So that's a quick and simple way to evaluate expressions using exponents. Here's some more examples. 4 to the third, negative 7 squared, and negative 7 squared. 4 cubed is simply 4 times 4 times 4. 4 times 4 is 16, and 16 times 4 is 64. Negative 7 enclosed in parentheses and then squared is going to be negative 7 times negative 7, which is positive 49. Now, this is different from negative 7 squared without the parentheses. The 2 only affects the 7, not the negative sign. So we have one negative sign and two positive 7 numbers. So this is going to be negative and then positive 7 times positive 7, which is positive 49. So overall, the answer is negative 49 because there's only one negative sign as opposed to two. And so make sure you understand the difference between these two types of problems and what answers they're going to give you. Now sometimes you may have to deal with a zero exponent. Now what you need to know is that anything raised to the 0 power is 1. 3 to the 0 is 1. Now what about negative 3 to the 0? Negative 3 to the 0 is basically the same as this expression. The 0 only affects the 3, not the negative sign. So this is going to be negative, and then 3 to the 0 is 1, so overall this is negative 1. Now in the last example, the negative 3, the negative sign is affected by the 0 because it's within the parentheses. So this whole thing is going to be 1. So make sure you know the difference between these two problems and what answers they're going to give you. Now other times you may need to evaluate expressions. For example, let's say if we want to evaluate a squared plus b squared, where a is 3 and b is 4. You might see that in a typical pre-algebra course. So the first thing you need to do is plug in the numbers. Replace a with 3 and b with 4, and then evaluate. 3 squared, that's 3 times 3. 4 squared is 4 times 4. 3 times 3 is 9. 4 times 4 is 16. So this adds up to 25. Let's try this one. 2x cubed minus y squared. And let's say that x is equal to 2 and y is equal to negative 3. Go ahead and evaluate the expression using those numbers. So let's begin by replacing x with 2 and substituting y with negative 3. Let's expand it. 2 to the third is 2 times 2 times 2. Negative 3 squared is negative 3 times negative 3. 2 times 2 times 2 is 8. Negative 3 times negative 3, that's positive 9. And 2 times 8 is 16. So we have 16 minus 9, which is equal to positive 7. And so that's the answer for this problem. Here's the next example. 2x squared plus 3x minus 5. And let's say x is equal to 5. Evaluate the expression. So let's begin by replacing x with 5. 5 squared is 5 times 5. And 5 times 5 is 25. 3 times 5 is 15. 2 times 25 is 50. So we have 50 plus 15 minus 5. 50 plus 15 is 65, and 65 minus 5 is 60. And so that's the final answer in this example.